Matrices. What are matrices and what exactly is a matrix? A matrix is a rectangular arrangement of numbers, variables, or expressions arranged in rows and columns. Let's look at a few examples. 2, 3, 4, 5. That's a rectangular arrangement of numbers. To show that it's a matrix, we enclose them in what looks like a square bracket. This matrix has 2 rows and 2 columns. Rows run horizontally, while columns run vertically. Taking the top leftmost element, that is the number 2 here, as the starting point, this is row number 1, row number 2, column number 1, and column number 2. Here's another one, A, B, X, Y, 2, and 7. This is a rectangular arrangement of variables and numbers. It has 3 rows and 2 columns. And another one, a rectangular arrangement of variables, expressions, and numbers with 2 rows and 3 columns. Each location that may contain a number, variable, or unknowns is called an element. And the number of elements will be determined by the number of rows and columns it has. And that information is written in the dimension of a matrix. The dimension or order of a matrix is given by the number of rows m followed by the number of columns n. Let's look at a few more examples with different dimensions. These are column matrices. They have 1 column. This column matrix has 2 rows and 1 column, therefore it has a dimension of 2 by 1 with 2 elements. This one has 3 rows, therefore it's a 3 by 1 matrix with 3 elements. The second matrix here is called a square matrix. This is because it has equal number of rows and columns. It's a 2 by 2 matrix with 4 elements. A matrix could also have a single row, and we call that a row matrix. This one has 1 row and 3 columns, therefore it's a 1 by 3 matrix with 3 elements. The next thing we'll be looking at is the coordinate system inside the matrix that addresses each of the elements inside it. Consider a 2 by 2 matrix called A with 4 elements, 2, 3, 4, and 5. And we usually use capital letters to denote matrices. It has 2 rows, row number 1, row number 2, and 2 columns, column number 1, column number 2. Each of the elements inside the matrix A can be addressed, and we use lowercase letters for that. It is addressed by the row number and then the column number. The element in matrix A at row 1, column 1 is 2. The element in matrix A at row 1, column 2 is 3. The element in matrix A at row 2, column 1 is 4. And finally, the element in matrix A at row 2, column 2 is 5. Remember, it is the row number and then the column number. Before concluding this introduction video, there are some special matrices that we need to know. The zero or null matrix. Every element in this matrix is 0. Regardless of the dimension of the matrix, each element in it is a 0. Next, the identity matrix. The identity matrix is a square matrix, therefore equal number of rows and columns, whose elements in the main diagonal are 1 and the rest are 0. In a 1 by 1 matrix with only 1 element in it, that element would be just simply a 1. In a 2 by 2 identity matrix with 4 elements, each of the elements in the main diagonal is a 1 and the other elements will be a 0. In a 3 by 3 with 9 elements in it, the elements in the main diagonal are 1 while the other elements are 0. This concludes our introduction video. We will continue with matrix addition and multiplication in the next one.